Hey everyone, and welcome. Today, we are diving deep into our planet's most critical life support systems. You know, the water we drink and the energy that powers our entire world. It's the stuff we use every single day, and really understanding it is the key to shaping our future. So let's get right into it.
Really think about it for a second. We turn on the tap and boom, water comes out. We flick a switch and the lights come on. It all just works. But behind these super simple actions is this massive, incredibly complex system that connects us directly to the planet's resources. In this explainer, we're going to pull back the curtain on that system.
It really helps to think of our planet as having a finite budget. We depend on Earth for, well, everything. But so many of its most vital resources, especially fresh water, they aren't infinite. They don't just replenish on a human timescale, which makes every single drop we use just unbelievably important.
So, how do we even know if our resources are in good shape? Well, we have to monitor them, right? And for our most precious resource, water, scientists have developed this kind of health checkup, a way to actually read the water and understand its condition.
Okay, so one of the very first things scientists check is something called turbidity. It sounds complicated, but it's really just a score for how clear the water is. If water is full of floating dirt or soil or other tiny little particles, it looks hazy, and that means it has high turbidity. But crystal clear water, that gets a fantastic clarity score, or what we call low turbidity.
And this one simple measurement tells a surprisingly big story. See, low turbidity gets a big green check mark because it means sunlight can get down to the aquatic plants, fueling that whole ecosystem. High turbidity, though, that is a major red flag. It can block out the sun, it can clog fish gills, and it can even hide nasty bacteria from the very disinfection methods we use to clean it.
Of course, turbidity is just one piece of a much bigger puzzle. To get the full picture of water health, scientists run a whole battery of tests. They're checking the temperature, the amount of oxygen available for fish to breathe, its acidity, that's the pH, and even the levels of nutrients like nitrates. It's really a complete diagnostic.
And they also use one of nature's coolest tools, something called bioindicators. It turns out some tiny aquatic insects are incredibly sensitive to pollution. So if scientists go to a river and they find these little guys thriving, it's a great sign the water is clean. But if they're missing, well, that's nature's alarm bell, signaling that something is seriously wrong.
All right, let's switch gears. We're going to move from the water we drink to the energy we use. And just like with water, our energy choices have massive consequences, and they generally fall into two very, very different camps.
So on one side, you've got renewable energy. The key word here is replenish. It comes from sources that either won't run out or that fill back up as fast as we use them. Think sun and wind. Then on the other side, you've got non-renewables. These are resources like fossil fuels that literally took millions of years to form and we're burning through them way, way faster than they could ever be replaced.
This chart really breaks it down. The vast majority of our energy, we're talking around 80%, comes from that non-renewable slice. In there, you've got everything we pull out of the ground. Fossil fuels like coal, oil, and natural gas, plus nuclear. And that smaller slice, about 20%, that's where you find the renewables, the power of nature like the sun, the wind, and water.
So we have this deep reliance on resources, and we know some of them are finite and have some pretty significant consequences. Now that sounds like a huge challenge, right? And, well, it is. But it's also a challenge we've been developing tools to manage for a long time, for both our water and our energy.
To really get why we need these tools, we first have to understand the impact. And this timeline, well, it tells a pretty clear story. The Industrial Revolution kicks off this massive increase in burning fossil fuels. And pretty much right since we started keeping reliable records, the data shows a clear corresponding rise in Earth's average surface temperature.
The reason for that temperature rise? It's all about greenhouse gases. When we burn fossil fuels for energy, we release gases like carbon dioxide into the atmosphere. And these gases, they act like a blanket, trapping heat from the sun and causing the whole planet to warm up.
And the consequences of this warming are really significant, and they're all connected. We're talking about rising sea levels that threaten coastal towns, more frequent and more extreme weather events, and serious damage to delicate ecosystems like coral reefs. These aren't just abstract ideas. They are documented changes that are happening right now.
But look, it's not all doom and gloom. Not at all. We have recognized these challenges, and we've created some really powerful tools to address them. Legislation is a perfect example. Landmark laws like the Clean Water Act of 1972 set the first real national standards for water quality, giving us a legal framework to protect our rivers and lakes.
And we've also developed some incredible technology. I mean, check this out. This is the multi-step journey your water takes before it even gets to your faucet. First, chemicals are added to make all the tiny dirt particles clump together. Then they're gently mixed so those clumps get bigger and heavier, and they sink to the bottom. The clearer water on top is then filtered through layers of sand and charcoal, disinfected to kill any remaining germs, and finally stored, safe and ready for you to drink.
And all of this brings us to the most important point of all. The laws, the science, the technology, they're all just tools. But tools are only as effective as the people who use them. And that is where we all come in.
This quote right here really gets to the heart of it. It says, "The good health of humans and the environment requires stewardship." It's not just about government rules or big corporate policies, it's about this fundamental idea of active personal care. So what exactly is stewardship? It's pretty simple, really. It's taking active responsibility for taking care of something. In this case, it's about making conscious choices as individuals, as communities, to protect these shared, limited resources we all depend on. It's about thinking of the long-term health of our planet in our everyday actions.
And that brings us right to our final question for you. We've seen how our water is tested, how our energy is divided, and how our choices have real consequences. So, knowing all this, what does stewardship look like for you? What's one small choice, one small change you can make starting today to help protect our thirsty, hungry planet?